Hi, I'm Tony Blinson, President of Clean Envisions. In this video, I'm going to demonstrate how a radiant barrier works in an attic space. But before I do that, let's first define radiant heat. Simply put, it is heat that's transferred from one object to another without touching. Our sun is a perfect example. When you stand in direct sunlight, you feel the heat even though you can't touch it. Radiant heat energy is transferred from a higher temperature to a lower temperature. The law of thermodynamics tells us that net flow, or transfer of heat energy, is always from a warmer object to a cooler object, unless work is done to move it in another direction. This simulator will show how this works. What you see is a representation of a typical residential roof assembly. Roof rafters and insulation that separates the living space from the attic space. There's a dividing wall between the two sides. Both sides have infrared bulbs that simulate the sun, a thermometer probe that's in the attic space, and also a thermometer probe that's located in the insulation. The only difference between the two sides is a radiant barrier on the right side, and is attached to the bottom side of the roof rafter. As you can see, all the probes are reading pretty much the same temperature. Let's see what happens when I turn on the infrared bulbs and raise the temperature around 140 degrees Fahrenheit, which is pretty common on a 90-degree summer day. You will also notice as the attic temperature increases on the left side, so does the insulation temperature. Insulation slows heat transfer, it doesn't stop it. Look what's happening to the attic temperature on the right side with the radiant barrier. It's barely moved. This clearly shows how a radiant barrier will reduce attic temperatures compared to a typical attic without radiant barrier. Now imagine if you have HVAC equipment and ductwork in the attic space. This extra heat will make it hard for the air conditioner to do its job. By reflecting the heat away from the attic space, the insulation will be cooler. Bonus rooms can be a big problem area because in many cases, it's over an unconditioned garage and under a lot of attic space. A radiant barrier can reduce attic temperatures and in many cases, solve your cooling problem. One question that you might have is, if the heat is redirected back towards the roof, will it damage the shingles? Well, studies from the Department of Energy show roof temperatures over a radiant barrier will increase less than 10 degrees Fahrenheit. Let's put it to the test. Here I am using a thermal infrared camera to show the temperature difference between the radiant barrier and the roof deck. As you can see, there is a temperature difference between the two attics. You can also see the cool blue temperature under the radiant barrier. I think this demonstration shows how an attic radiant barrier will keep your insulation cooler, meaning less heat will reach the living space. The end result means you spend less money to cool your home.